Hello and welcome to lesson 5.5. Today we're going to start out by looking at direct variation. Now ultimately we're looking at writing an equation of direct variation and then using ratios and proportions that involve direct variation. So to begin with, we're going to start out by defining what direct variation is. It says a function in the form of y equals kx, so this form right here, where k is not equal to 0. This is what we call direct variation. Then, when we break this apart, out of that y equals kx, x is our variable, but k has a separate name, and we call this the constant of variation, okay, or it's the coefficient. So the variables x and y are said to vary directly with each other. Now, you might also hear this. You might hear that something is proportional to or varies directly. So whenever I see any type of these forms, I automatically think about the equation y equals kx. So to begin with, we're going to look at example 1, and it says, is each equation a direct variation equation? If so, we have to find the constant of variation. So remember, direct variation is y equals k times x, and the best way to do these is to solve and get y by itself. So to do that in this problem, I'm going to subtract 5x from both sides. So that gives me a negative 5x. And then I'm going to divide both sides by 2, and I'm left with y equals a negative 5/2 x. So if you notice, I have an equation that looks very similar to this up here. I have my y equals, I have a negative 5/2, which is my k value, and I have my x. So this negative 5/2 is our constant. So I'm going to say over here, because it asks for a constant of variation, it says k equals a negative 5/2. For part B, it wants to know if this equation is a direct variation equation. So again, I'm looking for that y equals kx format. And when I solve for y, I subtract 5x, which gives me 2y equals a negative 5x plus 9. I divide both sides by 2, and I'm left with y equals a negative 5/2 x plus 9/2. Now, at the point that I don't have just y equals kx, I have this piece out here that's being added to, okay? I no longer have direct variation. So this is a big no, it is not direct variation. When we go and try to write a direct variation equation, we do have 2 steps that we have to follow. Okay, one, you first have to find the constant of variation, k, using a point other than the origin. Okay, so we cannot use the point, because if you think about it, y equals kx kind of looks like y equals mx plus b, with the exception of there's no b value. So if I were to graph this, okay, and this is just a really rough sketch, my b value is 0. So if we were to go and graph just y equals kx or y equals mx, it's going to look something like this. So when we're writing our direct variation equations, we can't use the origin 0, 0, because our k, or our slope, it could be something like this, or it could even be a negative slope. But if we use that origin to write the equation, we're never going to figure out what that k value is. So you have to grab one other point. Then our second step then is going to be to use the value of k to write an equation. So let's go ahead and take a look and see how this works. So example 2 says to write an equation of the direct variation that includes the point 4, negative 3. So I'm ultimately looking at the equation y equals kx because this is direct variation. Now from my coordinate point, I know that 4 is an x value and negative 3 is a y value. So what I'm going to do is I'm going to plug x and y in. So I have negative 3. I do not know what k is, but I know that x is 4. Now by solving for k, I can find my constant of variation. So I'm going to divide both sides by 4, and I'm going to find that k equals a negative 3/4. Now that I know what k is, and you do have to complete this step, I can write my direct variation equation. And I will say that y equals a negative 3/4 x. And this right here is my final answer. Let's try it again. Example 3 says to write an equation of the direct variation that includes the point -3, -6. So again, I have x and y, and I'm looking at y equals kx because that's direct variation. So I plug in a -6 for my y equals k times a -3. I'm going to go and I'm going to solve for my k value by dividing both sides by a -3. And my negatives are going to cancel, so I'm left with k equals a +2. And my equation then for direct variation is y equals 2x. And this is my final answer. For example 4, it says a new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of John's family weighed his or her dish, and this is what they found. Determine if the cost is proportional to the weight. Or in other words, is the cost vary directly with its weight? So what we have to do in a case like this is we have to see, is the k value the same for each person? So if I identify my weight as my x value and my cost as my y value, when I have y equals kx, if I want to get k by itself, I will divide both sides by x. So this tells me then that k is equal to y divided by x. So what I'm going to do now is I'm going to look at each person's ratio and see if it's the same. So I'm going to start out by looking at this, and I'm going to say that k is equal to my y value, which is 5, divided by 12.5. And this is going to give me 0.4. I'm now going to go and look at the next one, and I get k equals 4 divided by 10, which is 0.4. Then I'm going to look at the next one, or 2 divided by 5, which also equals 0.4. And then if I check my last one, I have $3.20 divided by 8, which is also equal to 0.4. So because these points are the same k value, that tells me that they all vary directly, or they are all proportional. Likewise, for example 5, it says, are these Dairy Queen prices proportional? So again, if my weight is my x and my price is y, we know that k is equal to y divided by x. We just figured that out in the last problem. So for my mini, I'm going to take $2.89 and divide that by 6 ounces. Likewise, I'm going to have $3.69 and divide that by 12 ounces. And if I divide these out, I see that the first one gives me 0.48, I'm going to say 2, and the next one gives me 0.3075. So at the point that the first two aren't even the same, I do not need to look any further, and I'm just going to say no, these are not proportional. For example 6, it says your distance from lightning varies directly. So automatically I'm thinking y equals kx. With the time it takes you to hear thunder. If you hear thunder 10 seconds after you see lightning, you are about 2 miles from the lightning. So in this case, because the varies directly tells me I'm dealing with y equals kx, when I'm dealing with a story problem, sometimes I like to plug in variables that make sense. So it says your distance from lightning varies directly with time. So that tells me that my distance is equal to k times my time. So now what this does is this makes this a little bit easier for me, because it says if you hear thunder 10 seconds, I know that I'm going to be plugging that 10 seconds in for my time. And it says that you're about 2 miles from the lightning, so my distance then is going to be 2. So now when I go to solve for k, I have k is equal to 2/10, or 1/5. So when I go and I write my equation now, I can say that my distance varies directly with 1/5 of my time. And this would be my final answer. For example 7, it says a recipe for a dozen corn muffins calls for 1 cup of flour. The number of muffins varies directly. So again, I have that y equals kx, or in this case, I'm going to say m for muffins varies directly with the amount of flour, so k times f. Write a direct variation equation with the number of cups of flour and the number of muffins. So if I go back and it says a recipe for a dozen corn muffins, so a dozen, remember, is 12. So I have 12 equals k times, I have 1 cup of flour. So this one tells me then that k is just going to equal 12, or the number of muffins I get is equal to, or directly related to, 12 times f, or the number of cups of flour. And our final example for today says your percent grade varies directly with the number of correct answers. So grade varies directly with correct answer. So I'm going to write grade equals k times the number of correct answers. It says you got a grade of 80 when you had 20 correct answers. Write an equation for the relationship. So you got a grade of 80 equals k times the number of correct answers was 20. So here I know that k equals 80 divided by 20, which is 4, or I can rewrite my equation as the grade varies directly with 4a, which is your answers. So this is for part A. Part B now says, what would your percent grade be with 24 correct answers? So the nice thing is I've already got all the legwork done with this, so I'm looking to find my grade when I have 24 correct answers, and 4 times 24 is a 96%. So my grade, if I would have gotten 24 correct answers, is a 96. Please let me know if you have any questions. Otherwise, I'll see you guys in class.